Morning everyone. So today we are going to study about chapter atom and origin of spectra and Bohrs theory of atoms. So first is origin of atom. We have studied about Rutherford's Rutherford's alpha scattering experiment. So in a Rutherford's alpha scattering experiment, there was a thin gold foil which have, suppose these are the nuclei of the different atoms, and alpha particle is doubly ionized helium atom. So it is alpha, it is two protons, two positive charge. So there was a scintillation counter here, means device to count the number of alpha particles which pass through it. So when that alpha particle passes through the foil, it strikes here and it produces scintillation here. Scintillation means like fluorescence, tiny fluorescent lightning. So this is alpha, two positive charge. So most of the, in his experiment, what he realized that most of the atoms pass through the alpha particle. Most of the atoms pass through the alpha particles without any deflection. So no deflection was there, and very few were there which were very few were there which were deflected by large angles, means only 1 in 10,000 were the particles which were deflected back by angle 90 greater than 9, by angle which is greater than 90 or 180. So very less atoms were there which were refracted by very large angles. So all these were counted by the scintillation counter, which is able to move along this axis. So what we come to know from this experiment is that there is a lot of free space in atoms. So 99% or more than 90% of the atom is free. So more than 90% of atom is free, and there is a nucleus positive charge which is concentrated at the center of the atom. Positive charge is concentrated at the center and electrons are around it, but most of the part is free. That is why alpha particle which is positively charged, so only the particle by which there is a head-on collision with the nucleus, it gets reflected back, because positive charge repels each other, and or which passes very close to it is deflected by some angle, or mostly pass through it without any much deflection. So let Z into E be the charge on the Z is the atomic number or number of protons in the nucleus, and E is the charge on proton, plus E is the charge. So Z into E, Z is the total charge on the nucleus, and 2 positive or 2E is the charge on the alpha particle. Now we have to find the now, because when the alpha particle was coming, it was having kinetic energy. Alpha particle was having kinetic energy, and when it was coming near to it, it was continuously repelled by the nucleus. So its velocity was decreasing. So here its kinetic energy is Ke, kinetic energy, and here its kinetic energy is 0, because it gets stopped before getting bounced back. And so all the kinetic energy here has been converted into the potential energy here. Here it's get converted into the potential energy. So what is the distance here? This is the distance of the closest approach. So the alpha particle does not penetrate the nucleus, it approaches it. So the distance of minimum approach is, the distance of maximum approach is R0. R0 is the distance of maximum approach. From this position it gets bounced back, the alpha particle gets bounced back. So potential energy is equal to, potential energy we know 1 by 4 pi epsilon naught, and it is q1 q2 by r squared. So q1 is the charge on the alpha particle, so charge on alpha particle is 2e, and charge on the proton is z into e. So z into e is the charge on the proton. So z into e is the charge on the proton, that is the total number of protons, and then is the distance. So distance between the alpha particle and the nucleus, distance between alpha particle and nucleus is the distance of the closest approach. So this is the potential energy, and this whole potential energy gets this whole kinetic energy has been converted into potential energy. So this is also the potential energy, this is also the kinetic energy. Kinetic energy here was equal to 1 by 4 pi epsilon naught 2e ze upon r naught. So from here we can find the distance of closest approach. What is the distance of closest approach? It is r naught. So distance of closest approach r naught is equal to 1 by 4 pi epsilon naught and 2 ze squared divided by k. What is k? K is the kinetic energy of the alpha particle. We know what is its kinetic energy when we are forming a beam. So from these calculations, the distance of closest approach comes out to be around 2.5 into 10 raised to power minus 4 meter, minus 14 meter. So this is the 2.5 into 10 raised to power minus 14 meter is the distance of closest approach. Means the atom cannot go, the alpha particle cannot come more close to the nucleus than this distance. It cannot come more close to nucleus than this distance. So this is also near to the radius of the this distance also near to the radius of nucleus. This is very close to the radius of the nucleus. Then there are the drawbacks of the Rutherford model. What were the drawbacks of the Rutherford model? We'll discuss, and then we'll continue to the Bohrs theory of hydrogen atom. So first is drawbacks of the Rutherford model. So very first drawback is, we know Rutherford model suggested that there is a nucleus in the center and there are electrons electron is revolving around the nucleus, because the atom is revolving around the nucleus. So to revolve around the nucleus, what does an atom needs? To revolve around the center, we need a centripetal force. Or we need a centripetal acceleration. So the electron wants to go in the tangential direction, but the nucleus is attracting it towards its center because of electrostatic force of attraction between positive and negative charge. So there is a centripetal force. Because there is a centripetal force, there is also a centripetal acceleration. So the centripetal force is equal to V square by R. V square by R is the centripetal force. mv square by R is the centripetal force, and V square by R is the centripetal acceleration. So this mass, where V is the velocity of the electron and R is the radius of the atom. So this is the centripetal acceleration. So this, it means that the electron is accelerated. though the speed of the rotation is constant, but its acceleration is there, so velocity is not constant. But in physics, it is a concept that every accelerated charged particle, every accelerated charge emits radiation. So every accelerated charge emits radiation. So if the electron is revolving with an acceleration, then it must be emitting its energy in form of radiation. And if it is emitting its energy in form of radiation, it means what will happen? Its energy will decrease. And when the energy is decreased, then if the energy is decreasing, then its radius will go on decreasing. Then the electron must follow a spiral path before it gets collided into the nucleus. So it will get a spiral path, it will follow, losing its energy, the diameter goes on decreasing, and finally it gets collided with the nucleus. But this is not the case. But Rutherford is unable to explain this, that why the electron does not get collided with the nucleus, why it is not emitting radiations. And the second drawback is about spectra. So because there are no fixed orbits, like today we study that the electrons are in first orbit or second orbit or third orbit, and between first and second orbit there is a space, there is an empty space where the electron never goes. But Rutherford does not explain anything about those orbits. For him, electron can be anywhere. For the Rutherford electron, if this is the we say this is the first orbit and this is the second orbit, either electron is in first orbit but or it is in the second orbit. This is what we study today. This is given by Bohr. But according to Rutherford, atom can be anywhere in this whole space. Atom can be anywhere in this whole space. So, but we know that electron is in discrete orbits. Electron is in discrete orbits. Electron is not found everywhere. It is only in discrete orbits, either in first orbit or in second or in third. So, this second thing also Rutherford was not able to explain. So, because and the spectra was also different, because for him, because the electrons can be anywhere, therefore the spectra must also be continuous spectra, but it is a discrete spectra. So what is spectra, that also today we'll discuss further in this lecture. Next we'll come to the Bohr's theorem of atoms. So according to Bohr, electrons are in fixed orbit. Electrons are revolving in fixed orbits and the energy of the electrons are quantized. So we will discuss about Bohr's atomic model in detail. So Bohr's atomic model. So according to the Bohr's model, electron revolves only in certain orbits known as stationary orbits. Electrons revolve only in stationary orbits. Only in stationary orbits. So what are stationary orbits? Second point is, what are the stationary orbits? So stationary orbits are orbits for stationary orbits. The angular momentum which is equal to mvr, angular momentum of the electron, because the electron is revolving around the nucleus. So electron is revolving around the nucleus, it has a mass m and it has a certain tangential velocity v. So, and there is a radius of the circular path r. So it has a angular momentum. Anything which is rotating has an angular momentum. Anything which is in the linear motion has a linear momentum. So atom has a linear momentum, and for stationary orbit, angular momentum is integral multiple of h by 2 pi. So there is a, what is h? H is a Planck's constant. H is a constant known as Planck's constant, whose value is around 6.626 into 10 raised to power minus 34 joule second. So this is Planck's constant. So according to Bohr's, according to Neil Bohr, for electrons revolve only in stationary orbits, and for stationary orbits, angular momentum is integral multiple of h by 2 pi. So it cannot revolve in any other orbit in which its angular momentum is not a integral multiple, means it can be 1 or it can be 2. We can suppose it like we have a lift and we are in the ground floor, and when we enter the lift, we can either go to first floor or second floor. We cannot go to a floor which is between ground floor and first floor. So after ground floor, only first floor will come. Anything in between cannot come. So similarly, it will be integral multiple, like n can be 1, 2 or 3. It cannot be 1.2 or 1.3. So angular momentum of the electron which is revolving in this orbit must be integral multiple of h by 2 pi, where h is the Planck's constant. So if electron is anywhere here, so suppose this is the first orbit and this is the second allowed orbit or second stationary orbit. So if electron is here, if electron is revolving here, then its angular momentum, suppose here its angular momentum is h upon 2 pi, and here its angular momentum is 2 times h upon 2 pi. So here it is 2 times h upon 2 pi, here it is h upon 2 pi. In between, it is somewhere in between. In between, the angular momentum is around 1.5 into h by 2 pi. But this is not allowed. According to Planck's, this is not allowed. Only the integral multiple is allowed. So it must be integral multiple, where n can be 1, 2 or 3. And this is also known as principle of quantization. Principle of quantization. Quantization, what is quantization? Quantization comes from the word quanta. Quanta means smallest unit, a small unit. Quanta means a small unit. So quantization means the small unit here is h upon 2 pi. H upon 2 pi is the smallest unit of the angular momentum which the electron revolving in an atom can have. So this is the smallest unit. Others, if the electrons can have the value only electron is quantized, means there is a minimum value of angular momentum which is h upon 2 pi, which is the quanta of angular momentum, and it can have value which is integral multiple of this unit h upon 2 pi. So this is known as the quantization. Quantization means there cannot be continuous values, there can only be discrete values 1, 2, 3 or 4. So like in lift, we can have first floor, second floor, third floor. So it is discrete, it is not continuous. We cannot go to 1.1, 1.2, 1.3. So this is the principle of quantization. Third thing is that in stationary orbits, electrons do not radiate energy. So when the electrons are in these stationary orbits, they do not radiate energy in these orbits. So this was the postulate which Rutherford was unable to explain. Fourth is energy. If the atom gains energy, so if energy is gained, so electron jumps to higher stationary orbit. It jumps to higher orbit, and if energy, it loses energy. So if energy is lost or released, then electron jumps to lower orbit. Obviously the orbit must be stationary orbit, it must be a allowed orbit. And we have Planck's equation. We have one equation known as Planck's equation. Planck's equation. So Planck was the name of the scientist. So according to Planck's equation, the energy of the energy of photon is equal to h into mu. H mu is equal to energy of photon, because it loses energy and it goes to the lower orbit. Suppose the electron jumps from this orbit to the lower orbit and it loses energy in form of photon, photon. So that photon travels in form of a wave, as light is a wave and light is made up of photons. So if light is released in terms of photons, so these are in form of wave, and because it is in wave, it has a frequency mu. So let mu be the frequency, h is Planck's constant, h multiplied by frequency is the energy of the photon. So h mu is equal to the, and because it releases energy, so how much energy is released? So if energy here is energy here was E2 and energy here was E1, so obviously higher orbit, in higher orbit electron will have more energy, higher energy. So if it is coming from E2 to E1, the energy is E2 minus E1, and this energy is equal to h into mu. This will be the energy of the photon. Now next we will study about the Bohrs theory of hydrogen like atoms. So we will study about atoms which are like hydrogen. So hydrogen like atoms. So as we know, we have a nucleus with charge Z into E, where Z is the atomic number of electrons, number of protons, and here we have a electron orbiting around it with velocity, tangential velocity V. Charge is minus E, so the radius of the atom is R. R be the radius of the atom. So we have the angular acceleration, we have the centripetal force because it is revolving, so there is a centripetal force. So F centripetal is equal to, we have mv square by r. Mv square by r is the centripetal force, and this centripetal force is equal to the force of attraction between two charged particles. The force of attraction between the nucleus and the electron is giving this centripetal force. So the formula for force between two charged particles is F is equal to 1 by 4 pi epsilon naught Q1 Q2 by R squared. So here also centripetal force must be equal to 1 by 4 pi epsilon naught, 1 by 4 pi epsilon naught. So Q1 Q2, Q1 is Z into E and Q2 is E. Q1 Q2 by R squared. R is, what is R? The radius of the atom. So mv square, and Bohrs condition is, because we are studying about Bohrs theory, so we'll apply the Bohrs condition here. So what is the Bohrs condition? According to Bohrs condition, mvr, the angular momentum L must be integral multiple of h upon 2 pi. It must be integral multiple of h upon 2 pi. So this is our first equation, and this is our second equation. This is our second equation. So squaring 2, square equation number 2 and divide by 1. Square equation number 2, so we will square this equation. mv square is equal to m square v square r square is equal to n square h square upon 4 pi square, and then we'll divide this equation by equation number 1, and what we'll get? We'll get r is equal to n square h square upon pi m z e squared. So write it as equation number 3. This is a this is equation number 3, which we will get on dividing equation 2 with equation, on dividing square of equation 2 with equation 1. This is the second equation. So after dividing, we can simplify it by bringing the r to left side, and all other terms will move to the other side, to the right side, and we'll get this equation. So this equation is what we want to study in Bohr's theories. We have to study certain relation between the radius and this number n, because everything is quantized according to the Bohr. So because it is quantized, so we'll talk about the we'll talk like first orbit, second orbit. For first orbit n is equal to 1, for second orbit n is equal to 2, and we'll try to find the relation between the energy of the electron in different orbits. So as the orbits are increasing or decreasing, the value of n is also increasing or decreasing, and with the changing value of n, we want to see the change in r or change in energy or change in velocity of the electron. This is what we are studying in Bohr's theory. So this equation, from this equation we need not to cram this equation. What we need to know from this equation is that R is directly proportional to n squared. R is directly proportional to n squared. What does it mean? It means if for orbitals we have, if the ratio of n, the ratio of angular momentum of the electron in different orbitals is, it is n times h cut, n times h upon 2 pi. So it is n, which is 1 ratio 2 ratio 3. If it is like 1 ratio 2 ratio 3, then the corresponding radius will be 1 ratio 4 ratio 9. So ratio 4 ratio 16. What does this mean? As the angular momentum, these are the allowed orbitals. It is first allowed orbital, second allowed stationary orbital, third allowed stationary orbital. This is fourth allowed stationary orbital. And what is the position of that orbital from the nucleus? The position will differ by 1. Suppose it is in nanometers, 1 nanometer. The second orbital will be at 4 nanometer, third will be at 9 nanometer, and fourth will be at 16 nanometer. It means like we have this. So these are the different orbitals. So this is the first orbital. This is first orbital 1. Second orbital will be at twice the second orbital will be at 4 times the distance. So if this is the distance, the distance of second will be 4 times. So suppose this distance is x, and this distance will be 4x. Second orbital will be at 4 times. So either the electron is here or electron is here. It is not present in between. When it jumps to next higher orbital, or angular momentum becomes 3 times, in the ratio 3 times, then the orbital will increase 9 times. So third will be, so if this is 4x, and suppose third will be here, it will be 9x, and then fifth will be 16x. So the distance between the orbitals will go on increasing. Distance between orbitals will also go on increasing. So this is what we want to know from this third equation. This is what this equation tells us. And then next we have for hydrogen atom, because we also want to talk specifically about hydrogen atom. What does talking specifically about hydrogen atom means? Because we are taking this is any atom, we are talking about any random atom whose atomic number is Z. And when we talk about hydrogen, what is the atomic number of hydrogen? It is 1. It is having only 1 proton, so it is 1. So whenever we say that we are talking about Bohr's theory for hydrogen atom, it means we are just talking about the Bohr's theory. This is the equation we are talking about. This is the ratio we are talking about. The only difference is, in spite of Z here, what we put 1, because for hydrogen it is 1. Or hydrogen like atoms, if we are talking about helium, so we will put 2 here. If we are talking about we are talking about lithium, we will put 3 here. So this is how we are talking about Bohr's theory of different elements. So it is only about changing the value of Z. So for hydrogen atom, Z is equal to 1. Because Z is equal to 1, so R will become n square h square and epsilon naught upon pi m e squared. So this is our 4 equation. So this is the radius for the hydrogen atoms. Still the same ratio will be there. This is the ratio. The only difference is, in spite of Z here, so in spite of Z here we have put 1. So it is pi m e square and not pi m z d square. So this is, we have converted Bohr equation to Bohr equation for hydrogen. Then now if we want to know what is the, for hydrogen atom, what is suppose this is the very first orbital in which the electron can be there. So this is the first orbital, this is the nucleus. So what is the R1? What is R1, or what is the distance of the first allowed orbital of hydrogen atom from its center. So if we want to find, we can find it from this equation. So putting the values we can find R1 is equal to here, in spite of n square we will find 1, because for first orbital n is equal to 1. For first orbital we will put n is equal to 1 here. We will put the value of epsilon naught here. We will put the value of h square, because h is 6.6 into 10 raised to power minus 34 joule second. We will put the value of pi here, and m will put the value of mass of electron here, and charge on everything we know. So when we substitute all the values, we find it is equal to 0.53 angstrom, or it is 0.53 into 10 raised to power minus 10 raised to power minus 10 meter. So 0.53 into 10 raised to power minus 10 meter, this is 0.53 into 10 raised to power minus 10 meter. What is this? This is the radius of very first orbital of the hydrogen atom. In hydrogen atom, the very first electron is at a distance of 0.53 into 10 raised to power minus 4 meter from the nucleus. Then is the for other atoms. So if we find we want to know about Rn. What is Rn? So radius of nth orbit. Radius of nth orbit will be, so if this is the radius of first orbit, in first orbit, in spite of n square we have put 1. So we'll put n square here. Again we'll put n square. If it is 2, we'll put 2 here, and 2 into 0.53. What is 0.53? The value of h square epsilon naught pi me square is 0.53, and then we'll divide it by z for any atom. Why? Because in the denominator it is z. Z is there, but for hydrogen we have put z is equal to 1. So this is the equation for the, and in angstroms, this is the equation for radius of nth orbit, or distance of nth orbit from the nucleus for any atom. If you want to talk it for hydrogen atom, put z is equal to 1. And if you want to talk it about first orbit of the hydrogen atom, z is equal to 1, n is equal to 1. Second orbit of this hydrogen atom, z is equal to 1, n is equal to 2. In this way, you can study about the different orbitals of different atoms, or about hydrogen atom or any other atom. So these are the steps we are doing. We are learning certain relations. Then in next video, what we'll do, we'll do the hydrogen atoms spectra, or the Bohrs theory of hydrogen. Particularly we'll study about hydrogen atom. So from these generalized equations we will make specific equations for hydrogen atom, because it is there in your syllabus. Hydrogen atom, the whole theory, and plus hydrogen atom in detail is there in your syllabus. Then is velocity in the stationary waves, velocity in stationary orbits. So velocity is equal to, so because from here we have mvr is nh cut upon 2 pi, nh upon 2 pi, mvr is nh upon 2 pi. So v is nh upon 2 pi into mr. So v is nh upon 2 pi into mr. What is this? This is the velocity of the electron in the orbit, in any orbit. From here we also want to know a relation. Now we want to put the value of r. So we have to put the value of r here. So why we want to put the value of r here? Because we want to know the because here, as we have seen here, we know the relation between r and n, how r is increasing or how r is changing with n when n is changing. So if we want to know this relation, other things must be constant. Therefore here it is n is there, but along with m, r is also there. So we have to substitute r, because r is equal to n squared. So we can put n squared here. So if n square is here and n square is in the numerator, they will get cancelled out, and V will be resultant V will be inversely proportional to the n. Here it seems like it is directly proportional, but there is a n hidden in R also. This is known as the explicit relation or implicit relation. There is a implicit relation of V with M due to R also. So we have to put the value of R also here. So V is equal to n h cat, and what is the value of R? So this value of R will put this is the value of n square h square pi m z square. So when we put all the equation, then resultant it comes out to be z is, so V is equal to z e squared 2h epsilon naught upon into 1 by n. So what is the relation? Final relation is V is inversely proportional to n. Final relation is V is inversely proportional to n. So this is what we need to remember. These, no need to remember these derivations. What we want to remember is this, that V is inversely proportional to n and R is directly proportional to n square. Why it is inversely proportional? So to know this, for the reason we are doing the derivations, but this should be in your mind always, that R is directly proportional to n squared and V is inversely proportional to n. What does it mean? It means the velocity of the electron, it will be inversely proportional. Means as the electron jumps from one orbit to the higher orbit, its velocity goes on decreasing. Means the maximum velocity of the electron, maximum tangential velocity of the electron will be in the very first orbit. After that, its velocity goes on decreasing. After that, its velocity will goes on decreasing. So these are the certain aspects of the Bohrs model. So we'll do in the next video. So till then, if any doubt is there, you may ask in the comments, or in the class we will clarify.